All right, so we're going to graph linear equations so using slope and y-intercept. And in order to graph a linear equation using slope and y-intercept, one of the things we need to do is to get y by itself. And so notice in this linear equation, the variable y is by itself. Now, slope-intercept form looks like this. So slope-intercept form has this form, y equals mx plus b, where the coefficient of x, that number you multiply an x by, that's the slope, and this constant is the y-intercept. That's where the graph crosses the y-axis. So in our example, we notice here that this linear equation is written in slope-intercept form. So I want to graph this, but following the directions, I want to graph this using slope and y-intercept. All right, so y is by itself, so that's slope-intercept form. So right away, I can determine the slope. So remember, the symbol for slope is at lowercase m. So the number I'm multiplying x by, or the coefficient of x, is 2. So my slope is a positive 2. And my y-intercept, the graph where the point of the graph where the graph crosses the y-axis is negative 3. So make sure you're careful. It is not a positive 3, it is a negative 3. And so from there, I can go ahead and graph this line using slope and y-intercept. So let's go and do that. So this is number 1, y equals 2x minus 3. All right, so to graph this, we need to first of all plot. So remember, to graph a line, we need at least 2 points. So the y-intercept is one of those points. So first thing you need to do is graph or plot the y-intercept. So the graph crosses the y-axis at negative 3. So we'll go along the y-axis and we'll plot the point at negative 3. So here's where my y-intercept is, at negative 3. Okay? If I label this, this is going to be called 0, negative 3. So x is 0, y is negative 3. Now I need one more point. So to plot that point, I'm going to use the idea of slope. Well, remember, slope is rise over run. And so I'm writing rise over run as a fraction. So I'm going to need to rewrite 2 as a fraction. Well, there are infinite number of ways to rewrite 2. So for example, 2 divided by 1, 4 divided by 2, 6 divided by 3, negative 4 divided by negative 2, things like that. So there's an infinite number. But we're just going to go ahead and make it easier on ourselves, and we're going to use this one. All right? And it doesn't matter, does not matter which one you use. You're going to, if you use any of these slopes right here, which they're all equivalent, they're all equal to 2, but if I use any of those, I will have the same line. I have a different point on the line, but it will be the same line. So it doesn't matter which of these you use. So I'm going to use 2 divided by 1. So remember, rise is 2, my run is 2, and they're both positive. Okay? So listen carefully what I'm about to say. All right, so from your y-intercept, from that point that's on the graph, I'm going to do the rise first. So rise, remember, means goes up and down. So I'm rising a positive 2. So that means I'm going to go up. If this was a negative 2, I would go down. So it's a positive 2, so I'm going to go up 2 units. 1, 2, so I'm right here. Now don't put a point here. Don't plot that point because you haven't done the run yet. So I went up 2. And I'm going to go, since my run means left and right. Rise means up and down. Run means left and right. Now, so I'm going to go up 2, 1, 2. And then my run's a positive 1, so I'm going to go to the right 1. Since it's positive, it was negative, I would go to the left. And there's my other point. So another point on that line then is 1, negative 1. And then all you do is just draw that line, and there's the graph. All right, so you would do this. You would say, you'd use a straight edge, and that line goes to those 2 points, and make sure you draw your arrows. And that's it. So that is the graph of the line y equals 2x minus 3 using slope and y-intercept. All right, let's look at another problem. All right, let's suppose we had this one now. Y equals negative 2/3 x plus 5. So notice it is written in slope-intercept form. So since it's written in slope-intercept form, I can go ahead and graph this line just by using the slope and the y-intercept. So the slope of this line is going to be the coefficient of x. So the slope is a negative 2/3. So negative 2 divided by 3. The y-intercept is this constant. So my y-intercept is 5. So I'm using the notation, so m for slope and lowercase b for y-intercept. Once I know that, then I can easily graph that line. So let's go ahead and do that. Now remember, to graph a line, you need 2 points. The y-intercept is a point of that line. That's where the graph crosses the y-axis. So that's going to be a positive 5. So I'm going to go up here. This is 2, 4. So there's where the graph crosses the y-axis. So that's the point 0, 5. And by the way, just to remind you, and I should have done that in the previous one. So remember, the slope is positive, right? So remember, if the slope is positive, the line needs to rise, and the line is rising. As you go from left to right, the line goes up. Okay. So when I do this one, notice the slope is negative, right? Slope is negative. So when I graph this, the line better go down like this. All right, so just keep that in mind. All right, so remember, I need one more point. So to get that point, I'm going to use the idea of slope. So remember, slope is rise over run. And so my rise is a negative 2, and my run is a positive 5. All right, so let's talk about that. All right, now remember, so we're graphing y equals negative 2/3 x plus 5. And so we know the slope is negative 2/3 and the y-intercept is 5. All right, so remember saying rise over run, right? Rise over run. So that's negative 2 divided by 3. All right, so from the point that's already given on the line, which is 0, 5, let's do rise first. So my rise is a negative 2. So remember, rise means goes up and down. You go up if it's positive, you go down if it's negative. Well, it's negative. It's negative 2, so I'm going to go down 2. 1, 2. So that's where I'm at. Now, don't put the dot there, all right, because all you did was rise. Now, let's do the run. The run is a positive 3. So that means you're going to, remember, run, you go left, right. So you can go to the right if it's positive. You can go to the left if it's negative. Well, it's a positive 3. So I'm going to go down 2 and then to the right 3. 1, 2, 3. And so there's the other point. So that point has coordinates 3, 3. And so then, oh, and by the way, just to show you, someone else, just to let you know, so remember, negative 2/3 is the same as 2 divided by negative 3, right? Those are equivalent. So if I use this one instead, just to show you, you'll get a different point, but it'll all be in the same line. It'll be collinear. So from this point, I'm going to go up 2 this time, 1, 2, and then to the left 3 because my run is negative. 1, 2, 3. And notice another point in that line is going to be, let's see, that's going to be negative 3, and that's 7. So negative 3, 7. And so notice that it did not matter whether you use negative 2 divided by 3 or 2 divided by negative 3, you get the same line. Does not matter. You get something like this. Okay? All right. So that is how you're going to graph a linear equation using slope and y-intercept. Now, it's always easiest, just to let you know, it's always easiest if they already have y by itself. But many times they don't, right? So let's just kind of remind ourselves how we can get y by itself. So let's suppose that we have this example. We have 3x plus, let's say, 5y equal, and let's say this is negative 10. All right, so let's say we have that. And let's say the direction says that you want to graph this line, this linear equation, using slope and y-intercept. All right, so to do that, we got to get y by itself. So let's go ahead and get 5y by itself. So I'm going to have to subtract 3x from both sides, just like this. And so I get 5y equals negative 3x minus 10, right? And then finally, to get y by itself, I'm going to divide both sides by 5. So I'm going to go ahead and rewrite this over. And so when I do that, divide both sides by 5, I get y equals negative 3/5 x minus 2. Okay? So negative 3/5 x, and then negative 10 divided by 5 is a negative 2. And so therefore the slope is a negative 3/5, or if I want to, I could say 3 divided by negative 5. Does not matter, right? And then the y-intercept is a negative 2. Now, since the slope is negative, my line better fall, correct? So it should fall. So let's go ahead and graph that one, just to see what it looks like. So my y-intercept is a negative 2. So remember, to graph the line, we need at least 2 points. So I know one of them already. So the one we're about to graph is this one, 3x plus 5y equal negative 10. All right, so I need to first of all plot my y-intercept. So my graph's going to cross the y-axis at negative 2, so that's right here. So that has coordinates 0 and negative 2. And then I'm going to use the slope, which is rise of a run. And let's go ahead and use 3 divided by negative 5, just so you'll see how to deal with a negative run. All right, so I plotted with my points. I need to plot one more point. So I'm going to remember rise is positive, so I'm going to go up 3, 1, 2, 3. And then my run's a negative 5, so I'm going to go to the left 5. 1, 2, 3, 4, 5. And so that point right here has coordinates negative 5, 1. Negative 5, 1, and there's your line. All right. And you can always, if you want to, now remember to graph a line, you need at least 2 points, right? Well, you could have easily messed up on one of those points. So what some students will do is they'll use both of these to just verify that this one's correct. So from your y-intercept, you're going to use, let's say, negative 3/5. So this time you're going to say down 3, 1, 2, 3, and then to the right 5. 1, 2, 3, 4, 5, and notice you get that point on that line. All right, so I think that should be enough to get you to understand how to graph linear equations using slope and y-intercept. Now, just to let you know, the equations I chose here, notice the y-intercept in every situation was an integer. Negative 3, positive 5, negative 2. That's not always the case. You could have a, and let me just kind of show this. You could have a situation where you may have something like this. Y equals, let's say, 3/2 x minus 13/2. I'm just making that up. So notice now this one's not that bad because 13/2 you could easily graph. So whenever you graph these, you really want to use points. And notice in every point I did, let me just go back and show you. Every one I did, all those points, you can look at every one. All those points I plotted were integers, because it makes it easier. If those are not integers, you're going to have to estimate where this lies in the plane. But if they're integers, it's easy to see where it lies in the plane. It's where those grids intersect. That's where it lies. So whenever graphing these lines, you want to, as best as you can, use coordinates that are integers. So notice those were integers. The other one we did were integers. See, integers. And then the third one we did, those were integers as well. See, all those were integers. All right, so whenever you're graphing lines, you want to, as best you can, make sure that your coordinates are integers, because they're easy to plot, because they're going to be located where those grid lines are located. If they're not integers, you're going to have to estimate where they're located. And remember, in graphing lines, you want to graph the line precisely what it looks like. All right, so this situation right here, back one, is not as easy as the other ones because my y-intercept is not an integer. All right, so let's just kind of talk about how can we do this. How can we graph this line right here so that the coordinates are integers, right? Using the idea of slope and y-intercept, I'm going to have to estimate. I'm going to have to estimate where that's located in the plane. So, for example, you have in this case, we'll call this number 4. We have in this case that the slope is 3/2, and that my y-intercept is a negative 13/2. All right, now that's not an integer right here. My y-intercept's not an integer. I would have liked it to have been an integer, but it's not. I know though that it is equal to, and in this case it's what, negative 6.5. That's what it's equal to, negative 13/2. So I can estimate in this plane where negative 6.5 is. So negative 6.5 is about here, and it's still an estimate because I'm guessing where half is on this y-axis. So I'm guessing it's about here in the middle. And then from here, I'm going to go rise over run. Remember, rise over run. So I'm going to go up 3 and then to the right 2. So I'm going to have to estimate. Now, you see how difficult this is going to be, especially if this was not in the middle, this was somewhere else. It would be a little bit more difficult to use rise over run. But since it's a half, it's not that bad. So I'm going to go up 3. 1. So you see that's right. It's going from here to here is 1, 2, 3. So that's where I'm at. And then I'm going to go to the right 2. 1. Oops, let's do this again. 1, 2, 3, and then to the right 2. 1, 2. So that's about where that's going to be located. All right, and so this coordinate here is 0, negative 6.5, and then this one is 2, and then negative 3.5. So keep in mind, though, that it is an estimate. So it's always best, though, to use coordinates that lie on the grid lines. All right, but that's how you would do this. That's how you would do this using slope and y-intercept. All right, so when using slope and y-intercept, that those are, if the y-intercept's not an integer, then you're going to be estimating on the coordinate plane your points on the line. Okay, so I believe that should be enough for you to understand how to graph a line using slope and y-intercept.